Welcome. Maharashtra State Board of Technical Education is coming with the lead Learning at Your Doorstep. The course is Utilization of Electrical Energy. This presentation will help students in achieving one of the course outcome of the said course, that is course outcome number 4, Electric Traction. The unit outcome of this presentation is, after learning this UO, student will be able to draw the speed time curve for the specified electric traction application. What we will learn today? Today we will learn speed time curve of traction system, simplified speed time curve. The key takeaways of this presentation are simplified trapezoidal speed time curve and simplified quadrilateral speed time curve. Let's see the concept map for this topic. In this slide, we will talk about the speed time curve of the traction system. The speed time curve is drawn between instantaneous speed of train and instantaneous time. The speed is taken in km per hour on the y-axis and the time is taken in seconds on x-axis. The speed time curve provides the complete information of the motion of the train. This curve gives the speed at various time instant after the start of run directly. The slope at any point on the curve gives the acceleration and retardation of the train at any point. Area under the curve gives the total distance travelled by the train during the given time interval. The speed time curve is mainly consists of 5 different periods. First is 0 to T1, it is notching up period. Then second is between T1 to T2 time, that is acceleration period. Third is between T2 and T3, it is called free running period or constant speed period. Fourth time period is between T3 to T4, it is called costing period or power supply cut period. And the fifth period between T4 and T5 is retardation or braking period. Let's see the various time periods associated with the speed time curve in detail. The first is notching up period. When the supply is given to the train, it will start to run slowly from its zero speed position and try to catch up its rated speed. This period is called as the notching up period. During this period, the current is maintained approximately constant and voltage across the motor is gradually increased by cutting out the starting resistance of the motor. And therefore, the tractive effort in this period is constant and acceleration remains constant during this period. The second is acceleration period between T1 and T2. During acceleration period, all the starting resistance has been cut. But as the voltage across the motor is constant, the current starts decreasing with the increase in speed. And finally, the current becomes constant. During this period, though the train accelerates, but the acceleration decreases with the increase in speed. And finally, acceleration becomes zero at the speed at which the tractive effort developed by the motor becomes equal to the train resistance. The third time period in the speed time curve of the traction system is free running period or constant speed period. In this period, the train runs at its maximum speed, which is attained at the end of the acceleration period. During this period, the motor draws the constant power from the supply. The fourth is the costing period or power supply cut period between T3 and T4. At the end of free running period, the power supply is cut off from the motor and therefore train is running under its own momentum. The speed of train starts decreasing due to its resistance. The rate of decrease of speed during the coasting period is known as coasting retardation. The last is braking period between T4 and T5. At the end of coasting period, the brakes are applied to bring the train to the rest position. During this period, speed decreases rapidly and finally it reduces to zero. In this slide, we will discuss the speed time curve for different traction services. You can see here three different speed time curves for urban service, suburban service and mainline service. In urban services, the distance between the two stops is comparatively short. Therefore, time required for this run is very small and therefore free run is not present in this service and also costing period is small. In urban services, the distance between the stops is longer than the urban services but smaller than the mainline service. Here also free run is not possible and costing period is comparatively longer. In mainline services, the distance between the stops is more and therefore free run is of longer duration and acceleration and retardation period is smaller in this service. Now we will see what is simplified speed time curve. The speed time curve of traction system is simplified in order to make actual speed time curve flexible for calculations, minimize the errors in calculations and to make calculations easy. The simplified speed time curve gives the relationship between acceleration, retardation, average speed and the distance between the stops which are needed to estimate the performance of traction service. The speed time curve is simplified into two different categories. First is trapezoidal speed time curve and second is quadrilateral speed time curve. In case of trapezoidal speed time curve, acceleration and retardation periods are kept same as that of actual speed time curve and the costing period is replaced by the free running period. The trapezoidal speed time curve gives the closer approximations of the conditions of mainline services. Second, in case of quadrilateral speed time curve, acceleration and retardation periods are extended and there is no free running period in the quadrilateral speed time curve. The quadrilateral speed time curve gives closer approximations of the condition of urban and suburban services. In this slide, we will discuss the simplified trapezoidal speed time curve. The graph shown in the slide shows the trapezoidal speed time curve. It consists of three different periods: acceleration period, free running period and braking period. T1 is the time of acceleration, T2 is the time of free running and T3 is the time of retardation. Vm is maximum speed attained by the train. Acceleration time T1 is calculated by Vm upon alpha, that is maximum speed divided by acceleration. Retardation time T3 is calculated by Vm upon beta, that is maximum speed divided by retardation. The total distance travelled by the train is calculated by area of the trapezoidal curve OABC, which is equal to the addition of the two triangles, that is OAE plus CBD. The area of the two triangles can be calculated by 1 upon 2 AD into OE plus 1 upon 2 BE into DC. This can be solved by 1 upon 2 Vm into T minus T3 divided by 3600 plus 1 upon 2 Vm into T minus T1 divided by 3600. After solving this equation, we can calculate the distance travelled by the train. D is equal to Vm upon 3600 T minus Vm into k, where k is equal to alpha plus beta divided by 2 alpha beta. Also, we can calculate the maximum speed Vm is equal to t minus under root t square minus 14400 kd divided by 2k, and 1 upon alpha plus 1 upon beta is equal to 3600 d divided by Vm square into Vm upon Va minus 1, where Va is the average speed of the train. Quadrilateral speed time curve. The figure shows the graph of quadrilateral speed time curve. V1 is the speed at the end of the acceleration period and V2 is the speed at the end of coasting period. The total distance d travelled by the train is calculated by the area under the quadrilateral curve. After solving these equations, we can calculate d is equal to 1 upon 7200 into t into V1 plus V2 minus V1 V2 into 1 upon alpha plus 1 upon beta. Please take up a quiz and check by yourself. In this presentation, we discussed the speed time curve, simplified speed time curve, that is trapezoidal and quadrilateral speed time curve. Dear students, for the detailed study of this topic, you can refer the book Art and Science of Utilization of Electrical Energy by author Mr. H. Pratap.